Hey everybody, this is Kyle. Welcome to part 2 of Digital SAT Math Test number 2. If you haven't seen the first video, I recommend that you watch that first. This is the second module, and I'm calling it Module 2B. It's the harder of the two second modules. I got the whole first module right, and so that's why I have the harder of the two second modules. So again, if you haven't seen the first video, go watch that. And if you haven't done this test, I would recommend you do the test first before we go through all the answers. The first one here, there's a system of equations, and they say, what's the value of y? So let's go to Desmos because we can solve the system really easily there. 3x equals 12. Negative 3x plus y equals negative 6. What's the value of y? That means that they want the value of y at the intersection point. All right, the solution is xy. The solution is the intersection point for the system, and the y value there is 6. So the first answer is B. Number 2, which expression is equivalent to 11x cubed minus 5x cubed? That's easy. You can just subtract 11 minus 5. You get 6, and it's 6x cubed. You don't subtract or do anything with the exponents, and so we get B. This one, how many solutions does this equation have? 66x equals 66x. Desmos isn't really going to help us here because if I type this in, it doesn't show us anything, even if I zoom out. So it might seem like there's no solutions, but we have to think about this one in our heads. Think of it like this. If you took an x value, it doesn't matter what it is, and you plugged it into this equation, and you multiplied it by 66 on the left side, and you multiplied it again by the same thing, 66 on the right side, aren't these two sides of the equation going to be equal? In other words, if you multiply something by 66, isn't it the same as multiplying it by 66? So in other words, no matter what number we plug in here for x, because it's the same on both sides of the equation, of course the left side is going to equal the right side, and that means that there's literally infinite solutions. We could pick literally any number for x. As long as we plug it in on both sides, it's going to be a true equation, so there's infinitely many solutions. Here, this one we have to maybe read a second. A proposal for a new library was included on an election ballot. A radio show stated that 3 times as many people voted in favor of it as people who voted against it. And then it says that 15,000 more people voted in favor of it than voted against it. 15,000 more. So how many people voted against the proposal? So this one might require a little bit of thinking. Okay. 3 times as many people voted in favor of it, and that was 15,000 more people. So maybe we could think of it like this. We can say x is maybe the number of people in favor, and they say that 3 times as many people voted in favor of it as the people who voted against it. And so x, the people who voted in favor of it, is equal to 3 times, we'll call it y. So y is against. So x is triple y, right? In favor was 3 times bigger than y. And we know 15,000 more people were in favor of it than against it. So that also means we can make another equation, and we could say that x, the number of people in favor of it, was equal to y plus 15,000. Why plus 15,000? Well, think of it like this. If x is the number of people in favor of it, let's say that was, I'm just going to make up a number. Let's say that that was 30,000. Well, that would mean that y would be 15,000 because there were 15,000 more that were in favor of it. So 30,000 is bigger than 15,000, and so in order for these to be equal, we have to add another 15,000 to the against, if that makes sense. Maybe that's confusing, but this equation also works. So we have these two equations. You can solve them now however you want, but maybe because we have the equations, we can go to Desmos. And this one is taking a while, right? For a number 4, it's more difficult than you would expect. So that's my system. If I zoom it so that you can see both lines, there is the intersection point. So that would be the solution. So when x is 22,500, y is 7,500. And x was how many people voted in favor of it. They want how many people voted against it. So they want the y value, which would be 7,500. Now, of course, you're probably thinking, couldn't I just work backwards from the answers? And you could have. And this is what you could have done. So just, this isn't, we don't have to do both ways. But if you were using the answers and testing them, and you said that these were your variables, you would say, oh, if A is the answer, right? If we didn't know it was the answer and we said, is A the answer? Let's check. That would be my y. And then my x would be 3 times as many as that, which would be 7,500 times 3, which is 22,500. And then you would just check from there and say, is that 15,000 more than 7,500? And you would do 22,500 minus 7,500, and you would get 15,000. So that's an easier way to do it. Looking back, now that we know the answer is A, we could have gone through and done that test as well. So if you don't want to write that equation, you could do it the way we did in pink. Okay, this one's going to be a little bit easier. Caleb used juice to make popsicles, and this equation here approximates the volume that he had remaining after he made X popsicles. And the question is, what does the y-intercept of this graph represent? So maybe first of all, we can go to Desmos. If you're not comfortable with equations, lines, we can graph it. And we can see that the y-intercept, remember that means the point where the graph crosses the y-axis. The y-intercept is at 30. And we could have known that from this plus 30 here. The question is, what does that mean in the context of the problem? Well, obviously the x-intercept or the y-intercept is 30, and so it's going to be one of the answers with 30 in it. So A and B can't be right. They don't have 30 in it. The question is that how much juice Caleb had when he began to make the popsicles? Or is that how much he uses for each popsicle? Well, remember, if the y-intercept is 30, the x that goes with that, it says there is 0. And if x is 0 when y is 30, we have this relationship here. That's what the point 030 means. X is 0 when y is 30. And what does x represent? X popsicles. So 0 is the number of popsicles when y is 30, which means in this context that when he hasn't made any popsicles yet, that's why x is 0, he has 30 ounces of juice, because it says that f of x is the number of fluid ounces. So Caleb has 30 ounces when he hasn't made any popsicles. In other words, when he began to make the popsicles, he's got 30 ounces of juice, and the answer would be C. How many ounces does Caleb use for each popsicle? This is just a little bit extra. It's this slope here, -5, the number in front of x. It goes down by 5 every time, because every time he makes a popsicle, he must use 5 fluid ounces. That's what that means. Okay, we have an angle in radians, 16 pi over 15 radians. What's the measure of the angle in degrees? The way that we always go from radians to degrees is we use this relationship here. We say 180 degrees is equal to pi radians. If you remember from trigonometry, if you've done that in Algebra 2, you know that a full circle, 360 degrees, is 2 pi radians. You probably learned that. Maybe you forgot it. But that's true. And then from that, we also know that if you cut it in half, 180 degrees, half of a circle would just be pi radians. So this relationship here, 180 degrees equals pi, is what we're going to always use to find the number of, or to go from radians to degrees. So we're in radians right now. So to convert to degrees, we have to put radians in the bottom of this fraction, because over here, it's almost like this is a fraction like over 1, right? So radians is on top. That's the units we're in right now. To convert out of radians, we have to cancel it by putting it on the bottom of this new fraction, and those will cancel. And on top, we're going to put it in degrees, and that'll be our new units, what we're converting to. And what am I going to put with these units, degrees and radians? We're going to use this relationship here. 180 degrees, so that goes with the degrees, equals pi radians, so pi radians. See that setup? And now the units have canceled. We're going to be in degrees in our answer, and all we have to do now is we can cancel out pi with pi, top and bottom, and so the answer is going to be 16. We could do 16 times 180. Those are the numerators, and then we could divide it by the 15 that's left in the denominator. So when we do that, I'm going to go like this in Desmos now. 16 over 15 times 180. And the answer, you can see there, is 192. So that would be 192 degrees, and that would be our final answer. So you can't really, as far as I know, you can't really use Desmos there until you have the equation set up. Once you have it, you can use it as the calculator. Which point is a solution? Okay, this is easy in Desmos. We're looking at a system of inequalities, and we need a solution. So let's type it in. To get the less than or equal to, you could just do less than, so shift and then the comma, which is less than, and then immediately hit the equal sign and you'll get the less than or equal to. Or there's this little thing down here in Desmos. I'll move myself. And you could see the symbol there. You could use that like keyboard in Desmos. But I like using my keyboard, so I'm going to just type it. X plus 7, that's the first one. Y is greater than or equal to negative 2x minus 1. If we look at this system of inequalities, they're both shaded, but the solution for a system of inequalities is where the shaded parts overlap. So where the purple and green overlap is all of this stuff over here in this section here, right? That's where the shaded regions overlap each other, right? You can see the green is down there and the purple is over there, so that's where they both are. And of course, you saw I can just hide these if you ever want to, you could do that. And so the question is, which of these points is in that region where both are shaded? And you could see pretty quickly, I hope, that it's D, 14, 0, and here's why. The point 14, 0 is right there in black, and clearly that is in the shaded region of both. If you test out all the other points by eyeballing them or typing them into Desmos like we just did, you'll see that none of the other ones are in that shaded region. The first one is not. You can see that now. And it's nice, Desmos will label these for you. That's A. A is wrong. B is also wrong. And C is also wrong. Okay, so the only one that's in the shaded region is D. D's the answer. Okay, let's check out this one. A right triangle has legs with lengths of 24 centimeters, 21 centimeters. The length of the hypotenuse is 3 root D. D is an integer. What's the value of D? So we can draw a right triangle. It doesn't have to be perfect. The legs are 24 and 21. Obviously, this isn't to scale. It doesn't need to be. The hypotenuse, they say, is 3 root D. Okay. What can we do to figure out D? Well, we know the Pythagorean theorem works for right triangles. A squared plus B squared equals C squared. C is the hypotenuse. So let's just plug in everything into here. 21 squared plus 24 squared equals C squared, which is 3 root D squared. I'm going to put that in parentheses, square the whole thing. And I think I could actually put this in Desmos. I'm not sure, but let me try it. 21 squared plus 24 squared equals, parentheses, 3 square root, you could just type SQRT, that gives you the square root, of D. But I'm going to change it. If I put D, Desmos gives you this little error. They only support equations with x and y. So just make D x instead, and it'll solve it that way. And x is really our D, no problem. Parentheses, squared. And let's zoom it out and see if we can find where that... Ooh, there we go. So this vertical line is the solution to this equation. We just need to figure out what that is now. Sometimes it'll show you if you tap it, but it's not showing me when I click it now. So let me zoom in, and I could figure out that, oh boy. Oh, it's 113. Okay, that's perfect. I thought it was going to be a decimal. So 113 would be the answer. If you did it out algebraically, obviously I'd recommend Desmos because of how relatively easy it was once we used Desmos. But, and by the way, D is 113, that's the answer. But over here, what would you get? Well, I would have to square 21, add it to 24 squared, and I'll do it if you want to see it. Let me take this part out. So that would be 1017. And now if I square both sides, or both of these parts over here, I have to square 3, which is 9. And then if I squared the square root of D, I just get D. So now, when I solve for D, divide by 9, that's where I get 113. So that wasn't that bad, but some people don't like squaring this product here. Maybe they forget to square both. They don't like squaring a square root, maybe. So if you're one of those people, just use Desmos. Okay, next one. Which of the following compares the means of the two data sets? So they both have 27 values. Oh, this is easy. So notice that it says the frequency of, let's say, the value of 30 is 2 in data set A and 9 in data set B. So that means there's 2 30s in data set A. There's 9 of them in data set B. But that's all nothing to worry about, because if you compare, look at the numbers in data set A. Most of the numbers are bigger numbers with the higher frequency. They appear more often. And most of the numbers in data set B are smaller numbers, which appear more often, like 30 and 34. So that means that if you looked at data set A, because most of the numbers are big, there's a high frequency of them, they occur a lot, and data set B is mostly smaller numbers, data set A's mean or average has to be bigger because its numbers are mostly bigger. So the mean of data set A is greater. Yep, that works. Remember, just think of this like grades in school. If you have a class where most of your grades are higher, you're going to have a higher average than a class where most of your grades are low. All right, so if you could just simply interpret it that way, this is an easy question. Similar triangles. We've got two triangles. Let's see, maybe we could draw it out. I'm just gonna eyeball it or make up my own example. Let's say X, Y, Z, and R, S, T. Why do I have to do that order? It's because X corresponds to R, Y corresponds to S, etc., etc. So those angles have to match up in the picture. They say angle Z is 20 degrees. Now, because these are similar, and Z and T are corresponding to each other, similar triangles have angles that are the same. At least the corresponding angles are the same. So T is also 20 degrees. And oh, guess what? What is the measure of angle T? 20 degrees. That's it. This here is just meant to throw you off. It doesn't matter how the length of the sides relate to each other, right? X, Y, and RS are these sides. And they say that double XY and you get RS. So RS must be twice as long. But that doesn't matter for the angles, because in similar triangles, the angles that are corresponding to each other are always equal to each other. The answer would be C. Number 11, this equation here is talking about Keenan making 32 cups. Okay, so that's a measure of cups of broth. X is the number of small jars, Y is the number of large jars. What's the best interpretation of 5Y? Well, obviously, because Y has to do with large jars, the answer has to do something with large jars. So it can't be B or D, right? Because Y doesn't refer to large jars, or I'm sorry, doesn't refer to small jars. So now, is that the number of large jars, or is it the total number of cups in the large jars? Let's see. 5 times Y. So because 32 is a number of cups, each of these, and 32 is over here, right? The units in these equations have to be consistent. So it has to be cups plus cups equals cups, right? We can't have some other unit. And so 3x and 5y are both a number of cups. So 5y is a number of cups, just based on the units. So it seems like it's going to be the total number of cups in the large jars. Remember, if, and also, A, the number of large jars, is simply what Y represents, right? Y is large jars, the number of large jars. So Y could be, 6 or something, or probably not. It could be like 3, but that would be the number of large jars, whatever Y is. 5Y is the total number of cups in the large jars, which means that 5 would be how many cups are in each of the large jars, right? We don't need to know that, but the answer would be C. What is the sum of the solutions to the given equation? This is a good one to use Desmos for, because we can find the solutions and then add them together. So x times x plus 1 minus 56 equals 4x times x minus 7. All right, as long as I typed it in right, yeah, that looks good. So we could see here that we've got two solutions, and they want the sum of the solutions. And so the sum of 7 and 2.667 would just be 9.667, right? So that would be the answer here. And when you have, so a couple notes. This decimal, you probably know, is going to be one that goes on forever. They just rounded it there. So it's really 2.66666, and it goes on forever. But so what I'm trying to say is I wouldn't round this to like 9.7 or 9.66 and cut it off, because the answer goes on forever. They only rounded it to the 7 here because they ran out of space. So when you fill in the answer on the SAT, you have to put in as many digits as will fit in the boxes. And I think that would be 1, 2, 3, 4, 5 boxes. One of them is the decimal point. So don't cut it off. This wouldn't be right. Neither would this. On a question like this where the decimal goes on forever, fill the boxes as much as you can, and that would be the right answer. Now, another way that you could do this one, I just want to show you what Desmos could do. Is we had 2.667 plus 7, and that was our answer. And you could see here, it could turn that decimal into a fraction, but that's a messy fraction, and that's actually what this equals. But it should be maybe obvious that that's not the answer, because it's a huge fraction, and obviously you can't fit that in the boxes on the SAT. There's too many digits. But if we change this to the repeating decimal that we know it is, 66666, Desmos is factoring that in. But watch what happens when I put enough sixes. Desmos says, oh, you must mean 2 2/3, right? 0.666, it's 2/3. So 2 2/3 goes on forever. And now, finally, did you see that? It switched it from this decimal. It went first from this fraction, really big, and then they said, I give up. It's just 9.66. But now if we keep putting more, watch what eventually happens. It changes it to 29/3 because it finally recognizes we want the decimal that goes on forever, right? So now if I put in as many as I want, it's still 29/3. So technically, that would be the exact answer here. So you could put that in for your box as well. We have a function here, 1/9 x minus 7 squared plus 3. and it says that it gives the metal ball's height above the ground, x seconds after it starts moving on a track, and x is between 0 and 10 seconds. Which of the following is the best interpretation of the vertex? So let's go to Desmos. Put this in, this equation. I'm just going to put the right side. The f of x isn't going to matter here. Okay, so we have this nice parabola, but they tell us x is just between 0 and 10. So maybe I'm not going to mess with that. So let's just try to think of it as having x values just between 0 and 10. So really only this portion of the track. And maybe I'll even put in, no, I'm not going to do that. But just think of it like that. So the vertex is 7, 3. They ask about the vertex. So the vertex, this bottom point, 7, 3. What does that mean in the context of this problem? Well, x is 7, which is the number of seconds. And so it could either, in the answer, say something about 7 seconds, because x, which is 7, is a number of seconds. But notice none of the 7s mention seconds. So we haven't gotten the answer yet. The other variable there, or the other number 3, which is the y value, in this case, y equals f of x. So if y is 3, f of x is 3, and f of x, it says, is the height. So if y is 3, the height is 3, and it says the height was 3, oh shoot, which of those is right? Well, it was the minimum height was 3, because the vertex, the minimum point, the low point on the graph, is a minimum, right? It's the lowest point. So the height must have had a minimum height of 3, and the answer would be A. And just a little bit more, why is it not C? Well, the ball didn't start moving at this point. The ball started moving at 0 seconds, which would have been this point here. It must have started up high and come down low and then went back up. So C would be incorrect for that reason, and A would work. This one looks tricky. It's intimidating, and it's a little bit tricky, but this equation is a real equation, and it gives the temperature from Fahrenheit to kelvins. Okay, that's another temperature. And it says if the temperature increased by 2.10 kelvins, and x is Kelvin. So if x goes up by 2.10 kelvins, how much would it increase in degrees Fahrenheit? Okay, so the easiest way, I think, to do this one is to just pick two different x values that differ by 2.10, right? So pick 1 Kelvin temperature, doesn't matter, and then try it again, but increase the temperature by 2.1. And I'll show you what happens. So go to Desmos, put in the equation 9 over 5 times x minus 273.15 plus 32. Okay, that's the function. Now, if I put in x equals, let's say 10, where is this going to be? Oh, way down there. Okay. So when x is 10, Kelvin is the temperature, 10 kelvins, Kelvin, the Fahrenheit temperature would be negative 441.67. Now let's see what happens if I increase x by 2.10 kelvins, which would make it not 10, but 12.10, right? I increased it by 2.10. And what is my new value? I might need to write these down. So when x is equal to 12.10, y is equal to, it said here, the intersection point, negative 437.89. And when x was 10, the other intersection point here, negative, when x is 10, y was negative 441.67. So the question is, what is that difference? Well, you probably could tell from 441 to 437, it's about 3 or 4. That's the only answer that makes sense. That's not a difference of 35 or 487 or 519. And if you really didn't know, you could just go like this, negative 441.67 minus, we're going to find the difference between these two, minus negative 437.89. And the difference, don't worry about the negative, the difference is just 3.78. That's how much they differ. So that's how I would do it. There's other ways that you could do it as well, but that might be quickest for most people, is just to say, oh, they tell me what the temperature has to increase by, so why don't I just pick my own x values, my own temperatures, and just make sure they're different by 2.10, and then put them in Desmos and see what the values become. Number 15. We're starting to get to harder problems now. This one is a table, x and y coordinates, and there's this line, it says, that goes through these points, and these points are on the line, right? So it says the y-intercept of the line is k minus 5, comma b. What's the value of b? Well, there's one important thing we have to remember. Any y-intercept, anywhere that the line crosses on the y-axis, has the same x value every time. It's 0. So if I made up I don't want to waste too much time here, but let's just make up a line, 4x plus 7. Look, the y-intercept has an x value of 0. So if this is the y-intercept, and this here is the x value of it, we know that that x value, k minus 5, it has to be 0 because that's the y-intercept, and the x value at the y-intercept is always 0. So we could solve this equation and see that k has to be 5. That's not the answer, but it tells us now that this k up here is 5, and this is one of my points on the line, and this k is also 5. 5 plus 7 is 12. So the second point now is 12, negative 15. Now I have my points. There's many ways we can do this, but one of the best is to go to Desmos, add a table in, and put in these 2 points now. 5, 13, 12, negative 15. If I hit this zoom button, it shows me the 2 points. I got to move myself. There they are. Now, if you want Desmos to tell you the equation of the line through those points, this is another cool feature Desmos can do. I'm going to type in this equation, y sub 1, which is this y here. And I'm going to type it in. I'm going to write this. I'm going to write y1 is approximately mx1 plus b. And you should recognize this as y equals mx plus b, the equation of a line. And we're looking for the value of b, which is the y-intercept. So why do I type in y1 is approximately mx1 plus b? Well, first of all, the y1 and the x1 are referring back to the table, so Desmos knows that we're going to use the points from the table. And I use the approximately because Desmos is going to approximate the line, right? It's going to guess or try its best. And sure enough, it nails it. You could see the line through the points. And I get my m, the slope is negative 4. The b, the y-intercept, which is our answer, is 33. So just to review how to type this in here, let me just tell you how to do that. Type y, and then hit Shift minus on the keyboard, and that lowers it. And then you could put your 1, and then arrow over to get it back to normal height. And then hold the Shift button and press the squiggly button next to 1. That is approximately. And then m, x, Shift minus 1, tab over, arrow over, plus b. Okay, so b, the answer would be 33. 16. We've got a messy equation. We'll go to Desmos. We can type it in, and then we'll talk about what we're looking for. Okay, they say one of the factors is x plus b, where b is a positive constant. What's the smallest possible value of b? So let's zoom this out. It's a cubic. You maybe can see it if I move myself, but kind of hard to see with this squished in, but you could tell it curves around. The 3 x-intercepts, which refer to the factors or the solutions, are negative 13, negative 8, and 0. So remember, if we were going to write these as factors, it would be x plus 13. It's always the opposite of what it seems to be. X plus 8, which is the negative 8 part, and then x plus or minus 0, which is the third intercept. And so these b values, if they're all in the form of x plus b, it says, so the b values would be either 13, 8, or 0, right? X minus 0 and x plus 0, those are the same thing. But it says b is a positive constant. 0 isn't positive, so that's not going to be our answer. The smallest possible value of b, these are the two possibilities. The smallest of them is 8. And so 8 would be the answer. Number 17, this one's really easy. I don't know why they put this so far at the end, because this one is usually a hard problem, but we'll take it. This is nice and easy. F of x equals 7x minus 84. The x-intercept, where it crosses the x-axis, is there, 12, 0. Hey, we'll take it. That was nice. 18. This certain park's got an area of that big number square yards, and they want it in square miles. A mile is that many yards. The way that we do this is first recognize that we're in square yards, which is yards squared. So my units are yards squared, or yards times yards, and I want to convert it to square miles, or miles times miles. So when I do my conversion, like I saw earlier with my radians and degrees, we want to cancel out yards and get it into miles, or square miles. So the yards have to go on the bottom, right? And if I put yards on the bottom here and here in these fractions that I'm going to multiply by, these cancel and these cancel. And if I have miles on top here and miles on top here, my units are now in miles squared or square miles. So I'm good. Now I just have to plug in my numbers. 1 mile, 1,760 yards, put it in both fractions, and now I just have to figure this out. This is really over 1 if you want to think of it that way. And so in the top, if I multiply by 1 and 1, I'm just going to stay with that number. On the bottom, I'm going to do both of these times each other. So what I end up getting is going to be 11,863,808 divided by 1,760 times itself. And Desmos tells us quickly that the answer is 3.83, which would be B. Okay, we're almost done, but these are going to get hard. This one's tricky. 1 gallon of paint covers 220 square feet of a surface. A room has a total wall area of W square feet. Which equation represents the total amount of paint, P, in gallons needed to paint the walls of the room twice? So it might be easiest here to come up with a number of to come up with what we want W to be, so that we can kind of control the situation. And you'll see what I mean when I start this. So why don't we say that W is 440. I'm going to pick a nice number that 220 goes into. So if W is 440, that's the total wall area of the room, but we want to paint the walls of the room twice, so we need to have double that, which would be 880. So we need 880 square feet of paint. 1 gallon covers 220 square feet. So if each of them covers 220, to get up to 880, I need 4 of them, because 220 times 4 is 880. So how many gallons do I need? That's what P is. P has to equal 4 in this case, 4 gallons, just based on the number I picked. So P is 4 when W equals 440. Okay, so I picked 440 to be W, and that forced P to be 4. Now let's take these numbers that we know have to work and plug them into each of the answers and see which one is true. If it's true and none of the other ones are true, that must be our answer. So does P, which is 4, equal 440 over 110? Ooh, yes it does, and I'm excited because I think that that's the answer. That works. Let's just test the other ones to make sure that they don't work. Does 4, which is P, equal 440 times 440? No way, that's going to be a huge number. So already B is wrong. Does 4 equal 440 divided by 220? No, that's what you would get if you forgot to paint them twice, right? I'm pretty sure, yeah, you would get that if you forgot to paint them twice, I think, yeah. So C is wrong. And then D, same thing as B, 220 times 440 is this massive number, not 4. So I love that method because this problem could be particularly difficult if you don't have concrete numbers to plug in. So do it that way if you want. Just pick strategic numbers that maybe this one goes into. You could have done it, and I'm sure some of you are going to do this a different way and get the answer. My brain thinks like this, and I like it that way. So if that made sense, do it that way. 20, this one's easy, even though it looks hard. Desmos makes it really easy. It's a system, and they say it has no solution. So before we go to Desmos, think about a system. Usually a system of equations looks like that. They have an intersection point, which is called the solution. If they have no solution, that means they have no intersection point, aka they're parallel. So when we go to Desmos, we're going to look for parallel lines. 48x minus 72y equals 30y plus 24. And ry equals 1/6 minus 16x. Now, this is something we haven't seen yet in this video. Desmos allows you to put in a slider for r, and we can slide this and it'll change the value of r, and based on what r value we're on, it'll turn the line at the proper angle. But remember, we need it to be parallel lines, so they have no solution. So our R values here aren't working with what they give us. So we have to tap here and change the range of R. Instead of going from what it was before, -10 to 10, maybe we need to go from -20 to +20, I don't know, and hit enter. And now we can see that we can go bigger or smaller, and still this isn't going to work. But notice that I'm getting really close over here to parallel. So I'm guessing it's going to end up being less than -20. So maybe I'll go like -40 to -20 just to keep the range kind of tight. I knew it had to be less than -20, so that could be like my upper number. And here I'm getting closer and closer. Let me zoom in so that I could see, and I'm also going to make these whole numbers. So put a step of 1, and that'll keep this as a whole number because I don't think it's going to be a decimal. Let's see. 34 looks good. I'm just looking to see if we could have known that by looking. And how do we know that these are parallel? Well, you can kind of see as I go all the way this way, pretty far, they're still the same distance away from each other. And if I go back this way, they're not getting any closer. So it seems like that's my test. It seems like these are never going to cross if r is -34. And so that would be, in fact, the answer. R equals -34. This is a doozy. Buckle up for the last two. There's only 22 questions, but this one's hard. So C, they say, is a positive constant. My favorite method for this question is to pick a positive constant for C and plug it in to the equation and then use Desmos to see what happens. So if I say, maybe C is, it doesn't matter. As long as it's a positive constant, it doesn't matter. If C is 20, let's replace C with 20 in the equation and type the equation into Desmos and watch what happens. It's going to be hard to type it, but that's okay. X squared divided by the square root of x squared minus c squared, but I said c was 20, so put it in like that, then tab all the way over, equals c squared, so 20 squared, divided by square root sqrt of x squared, tab over, minus c squared, or 20 squared, all the way over, plus 39. Now Desmos will graph this. There's two solutions, but they're both the same. We'll see. You could see that they're both, actually they're not both the same number. But let me figure out what both of them are. So the first one, the negative one, if you zoom it in, it's hard to see what it is, but it's about negative I'm just going to write down approximately. X is approximately equal to negative, I don't know, 43.567, maybe 43.81 or 83. I don't know. It doesn't really matter at this point. The first one is that, and then the second X value is about, let's zoom it back out. It looks to be about 42 or 44, excuse me. So maybe 43, this is 40, 41, 42, 43, maybe 43.8. Oh, yeah, they are the same. Duh, 43.83, okay, positive and negative. So which of the following is one of the solutions? You might say, well, how does this help? Well, remember, if C is 20, is negative C a solution? Well, negative 20 obviously isn't one of our numbers. So because C was 20, we could see that negative 20, A, would be wrong. What about B? Let's go here and let's type in negative C squared, or 20 squared, minus 39 squared. Was that one of our solutions? No. B is also wrong. What about C? Type it in just like you see it. Negative square root 39 squared minus C squared, which is 20 squared. Negative 33. We're getting there, but that's not an answer either. So it must be D. D would be the answer. Let's just confirm it. Negative square root C squared, which is 20 squared, plus 39 squared. Bingo. Negative 43.83, which is exactly what we came up with for our answer. So D must work. And then finally, 22, another one that's tricky, but we can come up with the answer. So we've got a quadratic. A and C are constant, so that's not very helpful because we don't know either A or C, but they give us enough information. They say that the parabola opens upward. It has a vertex at HK, so this is HK, but what else do we know? All right, I thought there was a little bit more. Oh, here it is. K is less than 0, so K is negative. And they say f of negative 9 equals f of 3. So if you have a parabola, remember, through the middle of the parabola is an axis of symmetry. It's symmetrical. So if f of negative 9 equals f of 3, that means that we've got these 2 points that are the same height, and that means their value in the function is the same, right? F of negative 9 equals f of 3. That means the height of the function at negative 9 is the same as at positive 3, which simply means that these two x values, negative 9 and 3, are equidistant. They're the same distance from the center line. You can kind of even see it in the picture, which just means that the vertex, which lies on the axis of symmetry, is right between negative 9 and 3. And the number right between negative 9 and 3 is their average. The average of negative 9 and 3 is the number right in the middle. So what's the average? You could put mean of negative 9 and 3, or you could have just done negative 9 plus 3 and divide by 2, and you get negative 3. So what's the point of that? It means that the vertex has an x value of negative 3. In other words, that's what h is. And k is negative. So this is a negative number. And if the vertex is negative 3 and another negative, it means that it's going to be somewhere down here in the negatives, right? X is negative, y is negative, and so the vertex is going to be somewhere down here at, this was negative 3, right? So we know all of that is true so far. Okay, now what else is true? Is C less than 0? Maybe. Is A greater than or equal to 1? Who knows? But there's an equation for quadratics, and it's to find the x coordinate of the vertex. It's negative b over 2a. Hopefully you've learned that. Again, the x value of the vertex is negative b over 2a. Well, we know that b is 4, and we also know the x value of the vertex already is negative 3. So if b is 4, because that's a, b, and c, and x is negative 3, we can say negative 3 equals negative 4 over 2a. And if you solve this for A, we can even use Desmos now. Let's just call A x, so Desmos solves it for us. What do we get? We could see, this is a pain, but A is clearly less than 1, right? So A is, I guess we could just solve it here. So we get the exact answer. Multiply by 2A, multiply by 2A, and we get negative 6A equals negative 4. Divide by negative 6, and A is, it reduces to 2/3, which is what that is over there. So A is 2/3, so is A greater than or equal to 1? No, 2 is wrong. Okay, so it can't be B because that says that 2 is the only one that's right. It can't be C because that also includes 2. So it's either A or D. Now is C less than 0? Let's see. Because the vertex is down here in this quadrant, the graph has 2 x-intercepts. We don't need to know what they are, but it's important to know that it has real intercepts. It crosses the x-axis. So now we can think back to the discriminant. Remember in the quadratic formula, the square root of b squared minus 4ac, that's the discriminant. And we know, hopefully, that when we have 2 real intercepts, the discriminant, b squared minus 4ac, is simply positive, right? If the discriminant is negative, that would be taking the square root of a negative, and that wouldn't work, and that's why we would get imaginary solutions or roots. But because it has 2 real solutions, these intercepts, this has to be greater than 0. It's positive. So now we can plug in our b, which is 4, our a, which is 2/3, and leave c as it is, and we'll solve for it. And when we do this, we get 16 minus 4 times 2 is 8, so 8 over 3, c is greater than 0. Subtract 16 from both sides. Negative 8/3 c is greater than negative 16. And to solve this, I am going to get, let's multiply by the reciprocal. These cancel. Multiply by the reciprocal. And c, whenever I multiply or divide by a negative with inequalities, the sign flips. These cancel to become positive 2, and 2 times 3 is 6. So it should be that c is less than 6. Is it true that c is less than 0? Not necessarily. C is just less than 6. It could be 4, 3, 2. So it doesn't have to be less than 0. And so it's actually the case that neither 1 nor 2 are correct. Hopefully we got them all right. Let me know if I didn't, but I think I did. Man, that was difficult. Hopefully that was understandable. Let me know in the comments if I made a mistake, if you want to see more, if that was helpful. Like this, subscribe, share the video, spread the word. Desmos is awesome. The digital SAT is tricky at the end especially, but Desmos makes it a lot easier. Good luck, and have a good day.